3.07. I'm sorry there's been an issue with Nearpod, but last week I put all the links to the videos and the notes in your WAG. I'll put the copy of the notes in your WAG again this week, but I'll just do the videos by themselves. Just make sure you are following along and putting them in your algebra folder. Once again, you will do the warm-up on your own, so this one and this one, it's just to get your brain moving and grooving, see what you remember from stuff you've learned before, okay? But let's get started on what we're going to learn that's new. So a blank is a function in the most basic form. So this is talking about a parent function. So a parent function, spelled just like parent, like you have a parent. Parent function is a function in the most basic form. For example, y equals x, or f of x equals x, where the slope is 1 and the y-intercept is 0. Okay, so for these two functions here, y equals x and f of x equals x, the slope is 1 and the y-intercept is 0. Now, if you'll remember, your slope is your m, okay, and your y-intercept is your b. We talked about that last week, but as a reminder, slope is m, y-intercept is b. Now, for this next little section, blank affects the y-intercept of the graph. We're going to be talking about a vertical, and if you remember, vertical is like this, up and down. Vertical translation. Okay, a vertical translation affects the y-intercept of the graph. So it looks something like this, fx plus d, okay, so notice plus d, shifts the y-intercept of the graph. If it's positive and we're going up and down, probably gonna go up, okay? F of x minus d, if it's negative and we're going up and down, then you're going to be going down, right? We can always associate positive with up and right. We can associate negative with down and left, okay? And since we're doing a vertical translation, we're talking about up and down. So if we add d to the y-intercept, it goes up. If we subtract d, the y-intercept goes down, okay? So let's look at a couple of examples here. So on this first one, it gives us the functional rule. So the functional rule this time is g of x equals f of x plus 4. Well, remember, if I'm saying plus 4, which direction am I going? Up, right? So you would say something like the graph shifts, okay? Right? We're talking about shifting it, right? We're not going to like turn and curve and swirl. We're shifting 4 units up. Okay? So, 4 units up to create graph G. So the original graph was f, right? So the graph f shifts 4 units up to create graph G. Okay? Now you can kind of paraphrase that. You don't have to put exactly what I said as long as it means the same thing. Graph f shifted 4 units up to create graph G because we have this plus 4 here. Okay? Let's look at that next example. The graph of f is shifted 2 units down to create the graph of G. So remember, if we're shifting down, it's going to look something kind of like this, right? So let's look. This time it gave you the description and wants you to write the rule. Remember, if I'm creating a new graph, the graph I'm creating is G, and it tells me that right here. It says create graph G. And then is equal to, now the original graph was f, and it tells me there right here. the graph of f. It shifted 2 units down. So now, instead of adding something, I'm going to be subtracting, and it said 2 units, so f of x minus 2. Okay, does that make sense? Kind of, sort of? We're going to do a couple more examples together, and then I'm going to let you do a few on your own. So, let's see. What do you remember about dilating a figure? Now, dilation is different from shifting, right? A dilation does what? And I know I can't hear you right now, but out loud to yourself, what does a dilation do? Changes the slope and steepness of the graph, right? It says it right here. Slope, steepness of the graph. So, what we recall, hopefully, from the 8th grade, is that a scale factor, to use a scale factor, so to use scale factor, and you don't have to write exactly what I'm writing as long as you know what I'm talking about, and it means pretty much the exact same thing. To use scale factor, you multiply. Okay? Multiply by scale factor. Okay? So, this vertical stretch or shrink affects the slope and steepness of the graph. Okay, if the scale factor is greater than 1, so this is bigger than 1, greater than 1, what happens? If I multiply something by something that's greater than 1, am I getting bigger or smaller? Bigger, right? So the figure is enlarged. Okay, so if that's true, right, a vertical stretch or shrink affects the slope and steepness of the graph, then when a is greater than 1, the graph is steeper, because I'm getting bigger, right? So I'm getting steeper and stretched. Now, what if it's between 0 and 1? So it's less than 1. What happens? Well, if it's greater than 1, it gets bigger. If it's less than 1, it's going to get smaller. So the figure shrinks. I don't know what happened with that little blue dot there, but shrinks. Okay? So instead of getting steeper and stretched, it gets less steep. Sorry, my messages keep going off. And shrunk. Okay, now slope affects the direction of the graph, right? If it's a positive slope, it's going to go, oh, I'm inverted, but if it's a positive slope, we're going to go up. If it's a negative slope, we're going to go down, right? So like somebody who is skiing, they're on a negative slope because they're going to go down the hill, right? You can't ski up the hill. Okay, so negative f of x changes the slope of the graph from positive to negative. Okay, so again, let's look at some examples together. Okay, take a look here, this first one, g of x, so the graph, the new graph being created is g of x. What happened to the old graph, f, is that we multiplied it by 1 over 2. Will you tell me, is 1 over 2 greater than or less than 1? Less than. So for the description, we're going to say something like the graph of g, because that's our new graph. The graph of g, okay, is, remember, if it's by less than 1, it's going to be less steep. I hope you can read my writing, sorry, is less steep than the graph of f. So because we multiplied by something less than 1, the graph got less steep, because we said right up here, right? If it's between 0 and 1, the graph gets less steep. Alright, now this one's a little bit trickier because now it wants you to rely completely on the graph, okay? So you are going to try this one on your own because that's going to be a tricky one, and I want to see if you can solve that on your own, but you're paying attention to what is the difference between the two. Now remember, G is going to be your new one, the one you created, and F is going to be your original. So you're going to tell me what happened on the slope from F to G. Okay, you're going to try that one on your own. And then that last one, the graph of F, is reflected over the x-axis to create the graph of G. Now, this is where it gets a little bit tricky, right? Because we didn't necessarily say what happens if it gets reflected. We talked about dilations. But look up here. It says negative f of x changes the graph from positive to negative. Well, if I flip something, I'm going to be changing the signs, right? If I reflect it, flip it, it's going to go from positive to negative, negative to positive. So what happens is G was created, the new graph was created because we had that negative f of x. It went from positive to negative, okay? All right, and then you are going to try this last page by yourself, okay? You're going to put together all the things we just talked about, and you are going to try this back page on your own. Remember, you are going to put this in your Algebra 1 folder. I will be checking those, making sure you have them, and put them in the gradebook for you, okay? All right, I will see you for notes 3.08.